Okay, so for Lewis structures, you only look at valence electrons. Okay, nou ons het klaar daai tabelletjie gedoen op bladsy 138 wat ons gesê het lithium byvoorbeeld het net een valensie elektron, so ons maak net daai een kolletjie en dan as ek nou 'n bietjie vooruitspring, suurstof het ons gesê het 6 valensie elektrone, so you fill up 1 2, those two go together, that's in the s orbital, they want to be paired, and then you fill 3 4 5 6. Dit het ons ook gesê dit maak nie saak as hy so lyk of hy so lyk. Dit maak nie saak nie. Solank daar twee pare langs mekaar is, they have to be next to each other, and then a single next to one another. Okay, so dis wat ons laasweek gepraat het van die loosstrukture.
Dan is nodig om te plan met die volgende leerders met dringend te kamer 20 te gaan. Jackie Jonas, Yassine Jacobs, Monica Oppel, Karen Pretorius, die Monica Oppel wat asseblief ook die draai by die kantoor maak een van die tyd. Dankie.
Okay. Now we're going to do Lewis structures of molecules. So ons is nog steeds besig met kovalente bindings. When is something a covalent bond, right, James?
Dan sê jullie jammer die leerders is nou wat gelees het met op kamer 16 te gaan. Jackie Jonas, Yassine Jacobs, Monica Oppel, Karen Pretorius onmiddellik asseblief.
Yes. Yeah. Yes, it's when there's a sharing of an electron pair. Now the first few that I'm going to show you guys is when they share one electron pair, and we call that a single bond that forms. So as ek 'n elektron het en Bianca het 'n elektron en ons deel hom, dan sit 'n enkel binde. Okay, so the first few examples that I'm going to do is going to be examples of single bonds. Now, I also mentioned this last week. Ek voel of julle laas week klas gehad het. In elk geval, ek het dit laas keer toe julle klas gehad het genoem that we follow the octet rule. Do you guys remember I spoke about that? Oct means 8. Okay, so every atom wants 8 electrons around him. Want dan lyk hy soos 'n edelgas. And remember, the noble gases are the stable ones. So as hy 8 elektrone om hom het, dan is hy happy. What's the exceptions? There's actually a few exceptions, but the exceptions that we work with at the moment is hydrogen. Want hy het nie plek vir 8 elektrone nie. Hy het mos net daai 1 s orbital. So he wants 2 electrons in his orbitals to be happy, and helium. So hydrogen and helium does not follow the octet rule. Why? Because they only have space for 2 electrons. So when they have 2 electrons, or 1 electron pair, then they're happy. Okay, as hulle 2 elektrone het, so julle weet hoe like helium sin. Helium has 2 electrons, so helium doesn't react. He doesn't bond to anything else. Want sy orbitale is vol. Hy's happy, hy's satisfied, maagie vol. Het julle hom? Selfde met waterstof. So kom ons kyk sommer gou na waterstof. So, hydrogen gas, as you guys know, is a diatomic gas. In other words, 2 hydrogen atoms bonded together. Waar kry ons kovalente bindings? Nie wat is dit nie, waar kom dit voor? Tussen wat en wat? We find them between non-metals, okay? So stem julle saam, waterstof en waterstof, die twee goeders wat in daai molekule is albei nie metale. So this will be an example of a covalent bond. Now immediately, covalent bond means they're sharing electrons. So wat gebeur is, jy het 1 waterstof, how many valence electrons does hydrogen have? 1. Do you guys agree? No? You've got 1 of them. How did I know that? Because it's in group 1 on the periodic table. Hy het net 1 electron, so hy het net 1 valence electron. Okay? And then I have another one. I'm going to draw it with a cross. Daar's hulle 2. Elkeen met sy 1 electron in sy orbital. 1 valence electron in its outermost energy level. So both of those are unsatisfied at the moment. Okay? Want hoeveel wil hulle altyd wil hoeveel elektrone hê? Both of them want 2. So what they're going to do is they're going to move closer together. Their orbitals are going to overlap, and then they're going to form this. How many electrons are there between those two hydrogen molecules? Hydrogen atoms. 2. In other words, this is 2 electrons, which means it's 1 pair. 1 pair of electrons means that this is a single bond. En 'n enkel binding. En julle sal sien in julle handboeke die heel eerste ene, hulle het hom nou net nie met 'n kruisie en 'n kolletjie geteken nie. Jy kan dit met 'n kruisie en 'n kolletjie teken soos wat ek nou het. Hulle het dit net met 'n kolletjie en 'n kolletjie geteken. I only draw it with a cross and a dot now so that you guys can see the one hydrogen contributes the one electron, the other hydrogen contributes the other electron. Né? So daar's daai gedeelde paar elektrone tussen hulle, so hulle is happy. Okay, now let's look at fluorine gas. We all know fluorine gas is also diatomic. Okay, kyk gou maar op jou periodieke tabel. Hoeveel valensie elektrone het fluor? 7. How many electrons does he have? He has 9 electrons, né? 9 elektrone, maar net 7 van hulle is valensie elektrone. How do we know that? He's in group 7. Okay, so it's going to look like this. 1, 2, 3, 4, 5, 6, 7. Het julle gesien, ek het eers die 2 saamgesit, en toe 1 by elkeen, en toe my ander 2. Presies soos wat jy jou afboudiagram teken. You must pair up the s orbital, then you move on to the p orbital, 1 for each, and then you go back. Okay, so we've got 1, and I'm going to draw this one this way around, so that you can see. How many unfilled orbitals does each of those fluorines have? Hoeveel ongevulde orbitale het hulle albei? Both of them have 1, né? So hierso's plekkie vir iets en hierso's plekkie vir iets. So what are they going to do? They're going to move closer together. Those 2 orbitals that are unfilled and unsatisfied will overlap, and then that becomes a shared electron pair. So hy gaan so lyk. Weer eens, jy mag jou nou met kolletjies gaan teken. Okay, now let's talk about the octet rule again. As ons net kyk na daai ene, hoeveel elektrone is daar nou om daai fluor? 8, né? Met ander woorde, sy energievlak is gevul. He has a filled energy level, so he's happy. If we go and look at this one, how many electrons does he have around him? 8. So do you guys understand the octet rule? They want to fill up the orbitals until each of them has 8 electrons between them. Okay, now, hoeveel pare elektrone deel daai fluoratome? How many pairs of electrons do they share? They share 2 electrons, but that's only 1 pair. So in other words, 1 pair of electrons means it's a single bond between the 2 fluorines. 'n enkel binding tussen die 2 fluoratome. Okay. Let's look at water. Okay. So water is 1 oxygen and 2 hydrogens. My oxygen has how many valence electrons? No, he has 8 electrons, but he only has 6 valence electrons. 1, 2, 3, 4, 5, 6. And this is why it's important to start filling your p orbitals and go around. Want dit is belangrik dat jy moet sien die 2 spasies lê nie so nie. It's not that it has a connection point there and a connection point there. The connection points are next to one another, not opposite one another. Why is this important? It literally sustains life. The fact that water does not bond with the hydrogens in a straight line, but at an angle, is why you are here. That is why you are living. So let's respect that. Ne? Okay. So they bond at an angle. Okay. So met ander woorde stem julle saam, hy het 'n plekkie daar en 'n plekkie daar. 2 orbitale wat gevul kan word. Okay. Now we have a hydrogen. I'm going to draw him here. He has 1 valence electron and another hydrogen who has 1 valence electron. So sien julle, hierdie ene gaan en sy elektron daar gaan insit en hierdie ene gaan en sy elektron daar gaan insit. Okay, we'll talk about it now. Let me just draw it first. Like that. How many electrons does hydrogen want to be happy? Onthou hy volg nie die octetreël nie, hy soek hoeveel? 2, right? So in other words, look at this hydrogen. Do you guys agree? He has 2 electrons. He's happy. Look at this hydrogen. How many does he have? 2 electrons. He's happy. Look at the oxygen. How many does he have? 8. You guys see? He has the 6 that he bought himself, and then 1 from the one hydrogen and another one from the other hydrogen. So he has 8. So all 3 of those atoms are now happier. All 3 of them are in a more stable state because of the bonds that formed. Onthou, wanneer hulle gevorm het, is hulle meer stabiel as voor hulle gereageer het. So almal van hulle is nou happier. But how many electrons is being shared here? Sien julle, dis 2 elektrone wat verdeel word. Nee, ek kyk nou net tussen die suurstof en die waterstof wat onder hom lê. Hoeveel elektrone Hoeveel elektrone deel daai 2? They only share 1 electron pair. So what happens is we have oxygen with a single bond to hydrogen and a single bond to hydrogen. 'n enkel binding na die een toe en 'n enkel binding na die ander toe. Jy sê nie hy het 'n dubbel binding nie. It doesn't have a double bond. He has a single bond to the one hydrogen and another single bond to the other hydrogen. Because there's a shared electron pair between oxygen and the one hydrogen. Shared electron pair means single bond. And then there's a shared electron pair between the oxygen and the other hydrogen. Nog 'n enkel binding. 2 single bonds. Yes. Ja, jy sê letterlik hy 2 enkelbindings. Nie 'n dubbelbinding nie. Ek gaan nou vir julle wys wat doen 'n dubbelbinding. Okay. I'm going to do one more single bond one and then I'm going to move on to the double and the triple bonds. Sien julle sover almal wat ons gedoen het was tussen nie-metale en nie-metale, so all of them classify as covalent bonds. Okay. And I'm going to tell you more about polar and non-polar covalent bonds in a minute. Okay, stikstof het hoeveel valens elektrone? 5. 1, 2, 3, 4, 5. Do you guys agree? It has 3 spots for orbitals to overlap. Nee? So hierso gaan 'n waterstof wees, hy het sy enetjie. Hierso gaan 'n waterstof wees, hy het sy enetjie en hier gaan 'n waterstof wees, hy het ook een. And they're all going to move closer to that nitrogen and then it's going to form an alone pair at the top. Ons noem dit 'n alleen paar elektrone. So that's also a lone pair. He's not sharing it with anything. So it's in a lone pair. This one has 1 at the top and then 3 spots next to one another. A hydrogen, a hydrogen, a hydrogen. Nou kom ons kyk wie of hulle almal gelukkig is. Hydrogen has 2 electrons. Is he happy? Yeah. Hydrogen has 2 electrons. Hydrogen has 2 electrons. You guys agree? All 3 of them are happy. Al 3 van hulle het 'n gevulde energievlak. Okay. Kom ons kyk na stikstof. Hoeveel het hy om hom? 8 elektrone. Okay. Now, look at the bonds. How many electrons is being shared between that hydrogen and the nitrogen? It's 1 pair of electrons. So in other words, we have 1 nitrogen with 3 single bonds. Hy het 3 enkelbindings. 1 enkelbinding na die een waterstof toe, 'n enkelbinding na die tweede waterstof toe en 'n enkelbinding na die derde waterstof toe. Not a triple bond, 3 single bonds. So if I ask you what type of bonds do we find in an ammonia molecule,